So, hello to everyone who is watching this. Today's practice, or I would say online lecture, will be about medical device reprocessing basics. Cleaning, disinfection, sterilization processes, regulatory documents, and process control. So now I will share screen. So, introduction to the reprocessing of medical devices, cleaning, disinfection, sterilization, process control, and regulatory documents. Actually, you as medicians in the future, as doctors in the future, you have to know what is going on behind you to feel safe. At least you have to know how medical devices are reprocessed and prepared for you. This lecture consists from 9 parts. Medical devices, division into patient infection risk groups, medical device regulation and related documents, microorganism inactivation on inorganic surfaces, washing disinfection, definition disinfected. Also, definition sterile, sterilization processes, inactivation factor, expiration dates for the prepared medical devices, and what it means, expiration date. Association of medical device reprocessing with surgical wound infection or surgical site infection, and control of medical device reprocessing processes. All this lecture will be divided in 3 parts. The first part topics will be medical devices, division into patient infection risk groups, medical device regulation, and microorganism inactivation on inorganic surfaces. Okay, part 1, and we will start. Medical devices, division into patient infection risk groups. Medical device, actually it's any instrument, device, mechanism, object or material which is necessary for the use of the device for alone or in combinations for medical purposes, for the diagnosis, prevention, monitoring, treatment, elevation of pain, compensation for injury, or for mutilation for the study, replacement or modification of human anatomy or psychological processes, or for the testing of medical concepts. So it means that everything what you use actually is a medical device. So it's apparatus or devices, as you see. In the same time, it's all types of instruments, and it makes no sense what kind of instrument it is. The same also is with medical device reprocessing equipment, sterilizers, washing disinfectors, and even swabs or cotton balls also are medical devices. That's very important. You have to understand that also those swabs and cotton balls also are medical devices. All medical devices, at this moment I'll start to speak about surgical instruments, are divided into patient infection risk groups. All of you know that here is a lot of classification systems for medical devices. For example, electrical shock risk, risk for the patients, risk for the users, and so and so and so. But here is one specific classification system. You don't know this, but at least you have to know that the system exists. It will, if you will know this, it will be easier for you to understand why sometimes it takes a lot of time to prepare instruments for you, and it cannot be done as fast as possible, yeah, or like that. So, and this classification system describes instruments in a previous contact with the previous patient, how it was, so its potential contamination. Then next step describes actions, what we have to do with this instrument surface to use this instrument safely for the next patient in the same contact. And this classification system divides all instruments in 3 groups. Low risk of infection or non-critical medical devices or instruments, medium risk infection or medium critical or semi-critical medical devices, and high risk or critical medical devices. Low risk infection risk or non-critical medical devices. Definition: it's medical devices or instruments which contact only with healthy undamaged skin. And what we have to do with this? Cleaning, it means pre-treatment. Always it will be really nice that it will be done at the place of application, and washing. Treatment is done manually. Washing can be performed manually or automated, depending on possibilities. Disinfect if necessary, and it's preferable to perform disinfection automatically, but it's also allowed to disinfect surfaces of surgical instruments in this group by immersing medical device in a disinfection solution. It's allowed, but it's not recommended to do this. Medium risk or semi-critical devices contacts with mucous membranes, saliva, or damaged infected skin. And those devices are divided in 2 groups. Why? Here it's really tricky. For example, we have a medical device, semi-critical. It's a forceps from dentist's office. It's quite understandable that those forceps were in contact with mucous membranes or saliva at least. But those forceps have no lumens inside or channels. And in the same time, we also have typical semi-critical device, flexible gastroscope or flexible bronchoscope. And difference is that those 2 devices have at least 1 channel. And here is a huge difference how to wash and disinfect channels. And that is why the second risk group, semi-critical devices, are divided into 2 subgroups. Subgroup A without lumens or channels, and subgroup B with lumens and channels. Difference between those 2 subgroups. If we have subgroup A without channels, then cleaning, pre-treatment at the place of application, and washing. Pre-treatment, the same as in group A, is done manually. Washing can be performed manually or automated, depending on possibilities. Disinfect, and of course it's preferable to perform disinfection automatically, but it's also allowed to disinfect surfaces by immersing medical devices in some solution. If necessary, sterilize. This third point depends on you, on doctors, because you know the kind of contact. We who are preparing medical devices, we don't know this contact, but you can inform us, and it would be really nice if you will do this. Inform us what was the kind of contact, and please sterilize also. It can happen. Subgroup B, specific. Semi-critical devices with lumens or channels inside. Cleaning, pre-treatment at the place of application, washing. Pre-treatment is done manually, and actually it's for all groups and all subgroups. Pre-treatment always is manual, but washing can be performed only automatically. Please remember that flexible gastroscopes, flexible endoscopes, or other semi-critical devices with channels, it's not allowed to wash manually, and it's not allowed to disinfect manually by immersing somewhere. Only automated. And of course, if it's necessary, sterilize. But the sterilization process, it's upon to you, because you know what was the kind of contact. High risk or critical medical devices. By the definition, breaks skin, penetrates subcutaneous tissue or mucous membrane, comes into contact with blood. Please understand, not only and comes into contact with blood, but or contacts with the blood. And here is the difference. For example, you have small manipulation with the patient, but accidentally this instrument contacts with blood without any breaking skin or penetrating subcutaneous tissue. In the same moment when this instrument contacts with blood, then stays high risk. And those high risk instruments are divided into 3 subgroups. Subgroup A, the same, without lumens, but difference is that they can be sterilized in saturated water steam or autoclaved. Subgroup B, with lumens, and it's possible to sterilize in a saturated water steam. And the last one, subgroup C, without or with lumens, but it's impossible to sterilize in a saturated water steam because of temperature. It means this subgroup C instruments, they can be or they will be damaged if they will be sterilized in a saturated water steam because of temperature. And this subgroup C is called also the highest risk medical devices. So, subgroups A and B, with or without lumens, but it's possible to autoclave. Point 1. Cleaning. Pre-treatment at the place of application, it will be really good. Washing always is preceded in CSSDs, and it means sterile supply departments. Pre-treatment, as I said earlier, always is performed manually. Washing must be performed only automatically. Disinfection must be performed only automatically. And sterilization in a saturated water steam or autoclaving. Subgroup C, without or with lumens, but it's impossible to sterilize in autoclaves. Cleaning, pre-treatment, the same as always, at the place of application. Washing, and washing must be performed only automatically. Disinfection also only automatically. And what's important here, disinfection automated only using thermal chemical low temperature method, and sterilization only by a low temperature method. That is why it's a high risk, because in both those steps, disinfection and sterilization, instead of saturated water steam, we are using chemical active agents. And yes, chemical active agents are not so safe as thermal disinfection or sterilization by using saturated water steam. But for all those groups, and it makes no sense what will be next step, there are performed between disinfection and sterilization several steps. Instruments must be visually inspected and maintained. The moving joints must be lubricated if necessary, or if we see that it's a defect, the damaged part or entire instrument must be replaced. After inspection and maintenance, the instruments are packed according to the next steps. Yeah, it can be different a little bit. It depends on what we are doing next step. Packing, it depends on the next step. And packages are always closed. When packages are closed, marking is replaced on a package or label. And 4 points, it's minimum requested information in this label. Point 1, the name, what it is. Next, data, when it was reprocessed. Then some identification, who did it, and expiration date. It's minimum 4 points what is necessary to place on a package. And now small video what we can check during this inspection and maintenance. Actually, you as medicians and doctors in the future, please, you have to understand that sterile technicians cannot detect all defects. Yes, we can check, we can control, but not everything, because we have no contact with the patient, we have no possibilities to check this instrument in a real function. Okay, as you see, we can check, but not everything. And now next, medical device regulation related documents. Yeah, that's also what you have to know. Actually, now starting from 2021, we have in Europe, in European Union, we have medical device regulation. Before this, we had medical device directive. Difference is that the medical device regulation is stronger than medical device directive. But it's only for European Union. All over the world, of course, there are different regulations about medical devices, but now I'll speak about MDR. This regulation was established in 2017 in April 5 with a 3-year transition period, but due to the COVID-19 pandemic situation, the transition period was extended until May 26, 2021. Starting from May 26, 2021, this regulation is in force. And what's different between this regulation and previously directive? Point 1, Article 2, definitions. Medical device means any instrument, apparatus, device, software, implant, reagent, material, or other subject intended by the manufacturer for single or combined use in humans for one or more of the following specific medical purposes. Okay, here is a lot of specific purposes, but one of these is products especially designed to clean, disinfect, or sterilize devices referred to in Article 1 and what it means. Earlier, when directive was in force, all sterilizers, washer disinfectors, sealers, or whatever to prepare, which were used to prepare instruments to reprocess them, it was just an applications. But now those devices also are medical devices. It's important to understand that it was changed. Article 25, identification. Point 1, point 2, okay, but in point 2 it's quite clear written that any health institution or healthcare professional must be identifiable, and it must be shown who delivered devices to them. It's really important because it's not only for medical device manufacturers but also for healthcare institutions, CSSDs. And what also is really tricky, medical device regulation changes the status of a number of medical device supplements by defining them as medical devices. As I said, sterilizers, washer disinfectors, sealers, and so and so and so. They were supplements, but now they are medical devices. Medical device regulation equates the medical device reprocessing units in healthcare facilities to medical device manufacturers. It means that all those technicians, all those units now are manufacturers, not only just a part of hospital, but they are manufacturers of medical devices. And why? Imagine, for example, a medical device manufacturer maybe it's B. Brown or KLS Martin or whatever, they are producing medical devices, forceps, clamps, retractors, and whatever. They always know possible contamination of their instruments when they are manufacturing them, and they have really strong and precise regulations what they have to do with those instruments. Hospitals or hospital CSSDs don't know, because every time every single instrument is a little bit different. In one surgery, contamination is one level, in another one level. And now, starting with this regulation, all hospital CSSDs also are manufacturers, because every time when we are reprocessing some surgical instrument set, we are producing brand new instrument set. It's a brand new product. And what also is tricky is that medical device regulation delegates reprocessing of single-use medical devices to member states. European Union is not regulating reprocessing or reuse of single-use medical devices. They are delegating it to member states. And it means that every country can decide what they will do, allow to reprocess and reuse or not. Of course, in this regulation it's written a lot of points of what can be followed to reprocess those medical devices, to reuse those medical devices, but every country can decide, is it possible for us or not? And of course, as I said, every country have its own regulations, especially if it's outside of European Union, but all of us, we have international standards. International Organization for Standardization is an independent, non-governmental international organization with a membership of 169 national standards bodies. What's important? Application of standards at this moment is free. You can decide it. Okay, I will use it or not. But national authorities can, and they are doing this, to set mandatory standards. They can do it, and they are doing this. And what's also important is that standards are not the teaching aids. The user of standard, for example, if I am deciding, okay, I will use standard, I must have a professional knowledge about this to use it. And I am responsible, if I am using this standard, I am responsible for consequences of my actions. It's written in annotation, and it's also very important. For medical device reprocessing, we have 7 groups of different standards, or I would say it's approximately 62 different standards for medical device reprocessing. It's requirements for validation processes, requirements for sterilization equipment or units, or requirements for washing disinfection machines, the structure and composition of chemical indicators, how to use them and which one, the same for biological indicators, requirements for packaging materials or sterile barriers, and of course several informative standards. So, and now the last point in this first part is inactivation of microorganisms on inorganic surfaces. Yeah, and this just for inorganic surfaces, not for organic surfaces. Yeah, what we know about, we have 6 groups. The prion, it's an infectious protein. I think you know, I hope you know. Viruses, bacteria, bacterial spores, fungi, and protozoa. About the prions, it's really tricky. It's infectious protein, and from one point we know that it's really easy to denaturate proteins, but it is not working with the prions. What we can do with the prion, it's moist heat or wet heat. We can destroy them starting with 134 degrees by Celsius, with the expiration time or exposition 18 minutes, or washing in alkaline solution where pH is equal or higher than 10.5. Of course, chemically also we can try to destroy them. It's hydrogen peroxide or ethylene oxide, but it's just a partly. Viruses, bacteria, fungi, and protozoa, it's really easy to destroy in a temperature range starting from 60 to 90 degrees by Celsius, or by using autoclaving starting from 121 degree with exposure time 16 minutes, or 134 by Celsius, exposure time 3.5 minutes. If we are speaking about bacteria spores, this temperature range 60 to 90 degrees by Celsius is not working. Bacteria spores will survive in this temperature range. Bacteria spores, with the presence of water, we can destroy starting from 120 degrees. And it's a different process. It's closed chamber, higher pressure, higher temperature. And that is why all over the world, for bacteria spores, we are using temperature 121 by Celsius with exposure time 16 minutes, and actually it's called autoclaving. Chemically, yes, we can destroy some bacteria spores, but not all. Not every chemical active agent can do this. So, and this temperature range from 60 to 90 degrees by Celsius is called thermal disinfection. Yeah, and one more point what you have to understand or have to know. Microorganisms are much more older than we, and they are living much more longer time than we on this third rock from the sun. And they are smarter than we. And actually it's all the time it's a race between us and them. From another point, it's impossible to destroy all microorganisms on the surface. Always someone will survive and will start reprocessing himself when it will be possible. Please remember about this. But about this we'll speak in the next part. At this moment, part 1 is finished.